Good morning. Hello, everybody. Welcome to our robotics class. This is week 14. Wow, how exciting. This week, believe it or not, we are actually finishing up Unit 2 in our curriculum that we've been using. What we've been doing is introducing you pretty much to the VEX Code VR, right? This virtual robotics program. And through Unit 1 and Unit 2, we've really been going over some very basic coding skills, right? Learning how to move our robot forward, learning how to turn our robot, and just use those blocks, right? So this is now all coming together, and we are now going to have our Castle Crasher Challenge, where you have to now knock down all of the castles. So last week, I believe we knocked down one, right, or two. And now we're going to work our way up to knocking them all down. And so this really puts all of your skills, you have to use them all, right? And you have to really think it through. And we are going to have a unit test. So I'll be going over everything. So if you take really good notes and you're really paying attention, you will do amazing. Okay, so I just ask that you really give attention to detail. Coding is just one of those things where you really have to be focused, right? Because if you're kind of off in la la land and then you come back and you're like, oh my gosh, what do I do? And you just try to attach some random blocks together, you'll never get the code right. It'll just be frustrating. So make sure you're following along with what we're doing, because pretty much I'm giving you all the answers. So no reason why you shouldn't get 100. All right, so welcome. This is lesson 4, Castle Crasher Challenge. So there it is. So we've already learned how to move the robot. We talked about that, forward and reverse, turning right or left. So during today's lesson, we'll be putting it all together. And so the drivetrain commands allow the user to control the movement of the robot, right? So we know these blocks already. Driving the robot forward and reverse, we use the drive 4 block. Setting the velocity of the robot, we use the set drive velocity block. And turning the robot, we use the turn 4 and the turn to heading blocks. So those are pretty much our main blocks. So I'll show you guys again in here. We learned how to use the drive forward and drive reverse. In the pull down menu, we can switch between forward and reverse. We learned how to use the turn block, turning right or left, and the pull down again, whatever you choose there. We also learned how to set our drive velocity, right? And so we know that the default drive velocity in the blocks is 50%, okay? So you can go anywhere from 0 to 100. And then there's the turn velocity block, right? How fast we're going to turn. Default's 50% for that block. So these are our main blocks that we've been using, right? So you should definitely feel comfortable plugging these blocks in. You should know what they do and have an understanding of them. If you need to go back to any of the previous lessons to review these blocks, please do so, because we're just moving forward, right? So we're going to keep building upon what we've learned. But you should know how to set the speed with your drive velocity, how to set the speed of your turn, right? How fast the robot's turning, how to make your robot go forward or reverse, and how to make your robot go left or right. Those are things that you should just know. Alrighty? Okay, so let's move on. So to create a working project, we have to use commands, right? And the order of the commands matter, right? So a sequence is a specific order in which behaviors are performed, right? An action or event leads to the next ordered action in a sequence. Sequencing is important for the Castle Crasher Challenge because the VR robot will only move exactly as the commands tell it to do. So for example, if I just put these blocks in any order, I just mix it all up. Now this is the sequence. This is an order. Whatever order these are in, so block 1, 2, 3, 4 is how the program's going to read it. So if you want the program to do something first and then second, and then third, you need to make sure you put the blocks in the correct order. If you don't put the blocks in the correct order, then when you press start and you run your code, it's just going to it's not going to do what you want it to do. So you have to think about the sequence in the correct order. So for the challenge, we're going to be knocking down all of the castles, right? So we see there's 5 castles. There's 1, 2, 3, 4, 5 castles. We have to figure out how to drive our robot around in the playground and crash into all 5 of the castles. So that's really our goal here. So we're going to have to follow steps to figure it out. So they have a little video where they show you how it should look, and they give you an idea. So I'll show you guys really quick. Let's put it on. So let's watch. So they're deciding to make the robots going straight. Robot is turning right and then turning right again and going forward. Turning right again and going forward, and turning right again and going forward. So they've decided to follow a sequence of drive forward, turn right, drive forward, turn right, drive forward, turn right, and that's what they're following, okay? So I would suggest that you start to think about your code in that way. Drive forward, turn right, drive forward, turn right. And this is what we're going to follow to build our code to solve the challenge, okay? So we're gonna go into our, I'm gonna go into the coding program now. So here I am. I'm going to rename this. So I'm gonna put my name. Please always put your name on the file. So I'm gonna put Mrs. Erica lesson number 4, and this is the Castle Crasher Challenge. So now we're actually doing it. So I've renamed it now. So now I'm ready to go. So now I'm going to think about my code. So let me open up my playground again. So I just described to you the pattern I'm going for. I want to drive forward, turn right, drive forward, turn right, drive forward, turn right, drive forward, turn right, drive forward. So the thing that we have to think about are a couple of different things. Well, we can easily look at this and we can see that we know our turns are going to be turn right, and it's going to be 90 degrees, right? Because we can see this is a square and we're following along the perimeter of the square. So we know that our turns are going to be 90 degrees. So that part of our code should hopefully be pretty easy. Turn right 90 degrees. The part that we have to really think about is our distance, right, in millimeters. And so not to complicate things, again, you can always use this trial and error. You can totally do that. You can put in some distances, test them out, see if it doesn't go far enough, try another distance. But everything with code is laid out on a grid. So if you can imagine, let me see if I can, I wonder if they have a grid here. Oh yeah, they have a grid map. So if you can imagine a grid, right? A grid has all of these boxes here. So you have lines that are going right to left, here, left to right, top to bottom, bottom to top. They have lines going and then they meet in the middle. So if you think about this here, anything that is going this way across, so going from left to right or right to left, we call this our x-axis, right? So this is our x-axis. And then anything going from top to bottom, bottom to top, that's our y-axis, okay? So that can help us when we're trying to figure out our distance, right? Because if we go back to our Castle Crasher, it tells us that currently our robot is positioned at 0, -800. So we can see 0, remember, is going to be right in the middle of the x-axis. So if it's this way, 0 is here, and then you're 1, 2, 3, 4, 5, 6, and then you're -1, -2, -3, right? And so if you're, so you know you're at 0, and then the y, remember your y-axis, anything going down is going to be negative. So we know -800. So if we think about that, we're like, okay, so we're about 800 away from the middle. And then if we go up, we're another 800. So if we add 800 and 800, that tells us the distance across this entire thing is about 1600 millimeters, right? So that can hopefully help us, because then we can take a look at this and we can think, all right, so I want to go all the way to the other side. But this is a very small castle, so we're not going to go the full 1600. We're going to try something a little bit less than that for our first time, right? And if you remember, because we already did this part, it was 1550, right? Because why? We weren't going the full distance, right? So we already knew the answer to that one because we already did this part of the code in the first lesson. So we know that the first step is going to be to drive forward 1550, right? But before we do that, we always want to set our drive velocity and our turn velocity. So let's pull those blocks out as number one. Drive velocity and turn velocity, right? And remember, if you need help with these blocks, you can always click the help button, click on the block, and it will tell you. Oh, I forgot what the drive velocity block is. Oh, it'll tell you. The drive velocity accepts a range from 0 to 100. You can use this block to get more accurate movement from the robot, and the default is 50, okay? So it tells you anything from 0 to 100. Now say you're like, gosh, what is the turn velocity block? You forgot about that one. Click on it. It says that the turn velocity will set the speed of the drivetrain, but will not cause the drivetrain to move. A turn block is still required, so you need to use that along with the turn block. And again, it can go from 0 to 100, and it can accept any type of number inside of there. Okay, so the default is 50 on that one as well, meaning that when you first pull it open, you'll notice these are both at 50. So I'm going to change them to 100. Okay, and now I'm going to get started on my code. So we already said we know that we're going to drive forward our first block for 1550, right, to get us. And then I'm going to open up the playground again. So now if we do that, we're going to crash into the first castle here, and then we're going to end up right over here. And now we need to turn right to be able to get over to this little castle in the upper right-hand corner. So I'm going to go back to here. I'm going to get my turn right. And we know we're using 90 degrees, so we could leave that alone because we know we have a square. And now we have to think about, we know we're going to drive forward again, but we need to think about how many millimeters. And we did already do this one, if you remember. It was like, I think it may have been last week's. And we know that the distance, because they told us, was 700 to get to this one. So what I'll do is I will plug in 700. Okay, so let's just test this out. Let's just see where we're at now. So I'm going to just test. So there's our robot going forward, knocking into the first castle, turning right, and knocking into the second castle. And so now we can see the robot needs to turn right again, and then it's going to drive forward again. So let's try to figure this out. So robot is going to turn right 90 degrees. So we're adding another one of those blocks. And then we have to think about how far the distance will be to drive forward. Okay, so we can take a look at this. So again, we're thinking about our square here that we're dealing with. And so then we know that, I'm just going to stop this for a minute. And then we know that we're going to come down here. So we're thinking about our distance. We know it's 1600 to go all the way down. So let's just try 1600. Let's see what happens. So I'm going to add in 1600. So now I'm going to open it again. I'm going to click start. Oh, wait, I have to reset it. Hang on. Let me open up the playground again. Reset our code. And let's run this. So our robot goes straight, crashes into the first castle, turns right, crashes into the second castle, turns right again. Let's see if it reaches. Yes, it did. It reached and it crashed into the third castle, right? And now we know we have to turn right again. So let me get another turn right and another drive forward. And let's just try 1600 again and see what happens. Let's see if that works. Okay. Here we go. Let's test it out. Drive forward, crashing into the first castle. Turn right, drive forward. Turn right again, drive forward, turn right again. Drive forward. Woo! Oh my gosh, he like crashed off into the thing. So we could maybe, let's try 1500 and see if he doesn't need to really go that far. Let's try 1500. So I'm just trying out some numbers, trial and error, seeing if I can make my robot be as precise as possible. That means as close to each of the castles and without going over and out of the playing field. So that looks pretty good because now if you look at the robot, when the robot turns right again, it'll be nicely positioned to hit this castle right about in the middle. And then let's try 1600 again. So we're going to turn right, 90 again, and then we're going to drive forward, and I'm going to put in 1600, see if that's far enough to get to the last castle. And let's see if we can get all of the castles. All right, so here we go. Robot is driving forward, crashing into the first castle, turning right, heading for the second castle, turning right, to the third castle, turning right, to hit the fourth one, turning right and going straight. Let's see if it's, oh, it did it, yay. So now we crashed into all 5 castles, okay? So I would say the code here is pretty good code, it worked. So this would be your code. I'll go through it with you again. We set our drive velocity, our turn velocity. Our first block was drive forward for 1550 millimeters. Then we turned right for 90 degrees, drive forward for 700 millimeters, turned right 90 degrees, drive forward for 1600 millimeters, turn right 90 degrees, drive forward for 1500 millimeters, turn right 90 degrees, and then drive forward for 1600 millimeters. And if we followed all of that code, we were able to crash into all of the castles and solve the challenge. Woohoo! So what I'm going to be asking you guys to do is to complete the code for the full Castle Crasher challenge. When you're done with it and it has been named, so remember it needs to have your name, lesson 4, Castle Crasher challenge. Then you will go to File, Save to your device, and you'll save it. You'll go into your email, and you will be able to go to Attach File, and in your Downloads file, you will see this file and you can attach it. Okay, so we've been doing this every week, and you guys have been doing a really great job keeping up with attaching these files the right way. I'm really proud of you guys. I feel like most, if all of you guys, except for the kids who aren't doing anything, and so I don't know where you're at, but the kids who have been doing it every week, you've been doing it correctly. So thank you for following directions and paying attention and getting this correct. So that's the first part of your lesson. The second part is you're going to get a link to the Unit 2 test. So we're going to just quickly go over these questions together. You're more than welcome to jot notes down. These are things that you already should have notes on because this is a review of everything that we learned in Unit 2. And there were 4 lessons in Unit 2. So the first question says, which of these best describes a programming language? So who remembers what a programming language is? A programming language is a set of rules where symbols represent actions. That's what a programming language is. And we're using a Blockly language now. We're connecting blocks, and the blocks are allowing us to then tell the program what to do. What is the name for an action performed by the VR robot? So think about that. Do you guys remember what it is? So it's a behavior, right? So a behavior is what an action that's performed by it. How do you change the behavior of the VR robot? What do you guys think? How do you change it? So you can change the programming blocks, which are called commands, and that will change your behavior. Pretty easy, right? In this example, it says, how far will the VR robot move based off this command? So it's saying drive forward for 300 millimeters. So we know that the answer is 300 millimeters, right? Because it tells us right there. What part of the block do you select to change the direction of the drive for block? So remember, there's the little pull down menu, and you can change it from forward or reverse, your little pull down menu. So that's how you change the direction. What is the default velocity of the VR robot? Hopefully you guys remember it was 50%. We looked at the help menu, remember, and we saw you could do 0 to 100, but the default was 50. What is the maximum velocity for the VR robot? We just said that. It was 100%, right? It goes from 0 to 100. How will the VR robot move based off of this command? So it says turn right for 80 degrees. So what do you think the robot is going to do? It's going to turn right 80 degrees, right? I feel like it's, they make it pretty easy, I would say. They tell you on the block exactly what it's going to do, right? Which block turns the VR robot to a given clockwise heading? And so if you remember the turn to heading block, I think we learned it last week. So that's the block then that would give, turn the robot to a clockwise heading, right? So that they're facing in the right direction. Okay, this is a little challenge. So you have to look at the code, and it says, what order will the buildings on the Castle Crusher playground be knocked over according to this project? So you have to just take a look at it and try to follow along. So they have their set drive velocity, set turn velocity. Okay, so we see the robot's driving forward. So it's going to knock into Castle 3 first. And then it's turning right, and it's knocking into Castle 2. And it's turning right, and then it's knocking into Castle 5. So it's following pretty much what we just did. It's turning right, going into 4, turning right and going into 1. So it was 3, 2, 5, 4, 1. So you have to find the answer for that. Which of the following is the best description of what the VR robot will do based on this project? So we set our drive velocity to 100. The robot's going to drive forward for 1,000 millimeters, turn right 180 degrees. Then we're slowing down to a velocity of 50 and driving forward to 1,000. So you just have to read through and try to figure out what it's going to do. So it's pretty much saying that the VR robot will drive forward 1,000 millimeters at the maximum velocity of 100. It will turn right 180 degrees, and then the velocity will then slow down to the default of 50, and then drive forward 1,000. So again, it's just teaching you how to read code. So you're pretty much just in words saying what would happen if you followed along line by line the sequence. So remember, start at the top, read down each line by line of code, and then you'll be able to figure out what it will do. And then the last question says, why is it important to correctly sequence commands in a project? Well, because you want to make the project work as it's intended to work, right? Otherwise, it's not going to do anything. So this is your test. Each of the questions is worth 8 points, except for number 10 is worth 12 points because it's a little bit longer. Please complete the test. So we now are moving into the break. So this is actually perfect timing for this. So your homework over the break is to complete the Unit 2 test and to complete the code for the Castle Crusher Challenge. So you'll be emailing me your code, and then you'll be taking the test. So you have 2 things to do for robotics class over the break. Okay, guys? So enjoy using this program. I hope you're starting to really get more comfortable putting lines of code together, reading code, understanding what you're making your program do, and just getting more comfortable with the whole thing, right? So I think this is a good place for us to stop. And when we get back, in January, then we can focus on building our skills and doing more things with this. All right. Okay, so reach out if you have any questions. Otherwise, follow the video, use your notes. I even told you you could use the video and the notes for the test. If anybody does poorly on the test, it really is a reflection of your lack of effort and care, because you have everything that you need to do well here. You have the answers, you have everything. So if you were just paying attention, you should get 100, okay? All right, guys, I'll see you next time. Bye.